APMM. Get paid to make.
Hello, welcome to B9 Creations. I'm Danny Mason and I'm going to be giving you a tour today. To get us started, B9 Creations manufactures high-precision 3D printers in about 70 countries around the world. Come on in, I'll show you where they're made. This is where you can see our offices. Our lovely Sarah, our office manager, isn't at her desk. And as you come along here, we have our Director of Quality and Business Improvements, as well as our customer support specialists who are experts in lean manufacturing. I'm sure you'll see some familiar faces down here. I want to take a moment and introduce you to a member of our sales team. Megan, do you want to tell them a little bit about yourself?
Hi everyone, I'm Megan. I've been with B9 Creations for a little over 2.5 years now, and I am in the sales department, so I'm sure I've met some of you, but nice to see you, and hopefully I'll get to meet more of you.
You get a twofer here.
Wow.
So this is Corey. He's our Director of Quality and Business Improvements, and you might recognize the man back here, Sean Anderson.
So I'm Sean, I'm the CEO of the B9 Creations team. We are extremely thankful to APMM. We originally got involved with APMM about 4.5 or 5 years ago when Jill Kennick bought a system from us and got me exposed to all the great things that APMM does. We really appreciate the opportunity to just plug into that community, learn from all the members about what it is to be a professional prototyper, designer, model maker, and how we can make our technology serve them better.
Perfect. Now we'll take you over to see what you've been waiting for, the prints. Thanks, Sean.
Yep.
Down here is actually where our product team is. That's everything from software to hardware. All of our mechanical engineers are down there working hard. So we're here with Eric Henriksen. He's our product manager, so he oversees our entire platform, software, hardware, and materials. Eric, do you want to let the APMM membership know a little bit about what you do and show them some of the cool parts you have here?
Sure, yeah. So as product manager, I kind of help identify gaps that we have in our product portfolio, both in terms of existing products, whether that be hardware, software, or materials, that have various other applications that we're not targeting at the moment, or whether that be products that we just simply don't have and need to start developing. So I talk to customers and gather information and turn those into specifications that we use to build our products or make our products better. This is the full build area of our new XL printer. We have a few of our smaller, very high detail components. These are made using a resin we call HD Slate. That was a reformulation of a material that we've had for quite a while. We have some cool new materials here. We've got, this is our rugged material. It's kind of similar to a nylon, where you get a little bit of flex, you got high impact resistance, but it's still kind of a more rigid, firm material. And we have our new resilient silicone material here, which on the surface looks pretty similar to some of the other black materials I've got on my desk, but has some pretty cool qualities and kind of mimics silicone or TPU type of material.
Well, thanks.
Yeah, no problem.
So a key part, as you can imagine, of our product line is our material suite. Because of that, we actually have a strategic partnership with this company you see in here, SDC Technologies, and we also staff it with our own PhD photopolymer chemists, so that those materials that you saw Eric showing you are ones that we can formulate, perfectly engineered for your application on demand. So this is the lab space where we do that formulation. And then if you come back here, I'll show you where we actually manufacture the printers themselves, as well as do all of our fulfilling and shipping and distribution. If you can imagine, just a short time ago, we were doing all of this out of a facility that was about a quarter of the size, shipping to 70 countries, and so being in this space has been incredibly helpful for us. Part of the secret sauce of our technologies is actually our resin vats. And we formulate them through a special process that you see in these clean rooms here. If you think about it, the window itself is like an optical device. So you want to make sure that it's perfectly calibrated and clear, and that's why we do it in these clean rooms. These are the actual production lines that we manufacture the equipment on. You can see one in progress there. And the neat thing about our technology is we actually do it for a variety of applications, all high precision, all very fast. But we have a dental partner who's an OEM, and we produce machines that go out with their name on it. We also have a medical division that produces medical equipment compliant 3D printers. Those you see here with the gray sides. And then these are the ones that are industrial grade 3D printers. So we have a couple different models, a 530, a 550, our new XL that you heard Eric talking about, which is our largest format printer, all with effective resolution finer than 25 microns. So you don't have to pick between a larger build size and that high accuracy and surface finish. After a part is printed, it goes into our automated cleaning unit so that the first time you touch a part, it's clean and dry, and then we post-cure it in UV light. And that whole process takes under an hour. So you can do a lot of design variations in pretty rapid cycle time. Well, that's our tour for today. We're so excited to be with you and answer any and all questions you may have. Talk soon. So that gives you a little bit idea of what our facility looks like. And just to give you a scale, when I say, you know, high resolution, I was joking with Jill that we were given a piece to print. And so we printed it in inches. And we asked the customer, like, is this what you want? Because we got it, it's all dimensionally accurate. And what they actually said is, no, we need that in millimeters. And so we did it. And this part you see, I have here in a 2 by 2 by 4 millimeter. That's what that part is. And it came out perfect. Oh, wow. And that's actually for a major medical device manufacturer that we did a show at Johnson & Johnson. So that's the scale we're doing, whether it's, you know, surgical drill guides and dental, or a lot of times even in the industrial model making space. Eric showed one of those lawgivers here. So you can see you want that kind of detail. And so we have resins that are formulated specifically for that, as well as engineering and biocompatible and flexible elastomers and silicone as well. So we ship to about 70 countries around the world, and everything from jewelry, medical, model making, research, prototyping, that whole range of things, but always with about a build table size that looks like this. So there's, you know, a lot of people are like, oh, that's small and it's plastic. Do you really capture a lot of opportunity there? And as Sean, our CEO, who you saw here, always likes to say, if I went out into the parking lot and took apart my Ford, you know, F-150 by not part size, but part count, how many of those would be plastic and fit in a shoebox? A lot. And I know a lot of what you guys deal with is probably on the high precision and potentially smaller end of the spectrum too. So I will pause there. I'm happy to talk about anything from the technology to platform to customers we work with to questions that you guys all have about our company or how additive would work with what you guys are doing.
What is the build field on that XL, Danny?
So this is roughly about 5 to 6 inches tall. Hi, I have it in millimeters, so I'll convert it to inches. And it's 70 millimeters long and about 125 in this dimension. So roughly, you know, about 5 to 6 tall, 4 to 5 wide, and then about 3 inches here.
And on that XL, you're printing at better than 25 microns?
We are, yep. So
go through.
Yep, in the X and Y. So the same type of resolution that you see that came off of this, which was printed at finer than 25 microns, you can still get at a build volume this size. And that's through a mix of a technology upgrade that we did in the printer, as well as a software, and it works retroactively. So people that, you know, already have one of our printers that don't want to upgrade to a bigger size, it will double whatever resolution they're experiencing currently. So, so if they have a 30 plane, you know, it goes to finer than 15. So it's pretty.
So it's a firmware upgrade for any of the core series?
Yep. It's a software firmware technology upgrade basically for anything. Because one of the core tenets of our brand, we always say we're not a big company. You saw the entire facility here, and so we don't have a ton of money to outspend, outdevelop, etc. But we try to do a really good job about listening and not leaving customers behind. So things we develop, whether it's this formula, which actually was a model maker's recommendation because they weren't finding an off-the-shelf material that met their needs. So we worked with them to develop one and then release it more widely. To your point, Jill, how can we, when we develop new technology, not just incorporate it into products moving forward, but give everyone who's been with us, from the beginning, a path to upgrade to the latest and greatest too.
For those of you who don't know or don't recall, this B9 is a Kickstarter company, one of the few real successful Kickstarter companies.
Yeah. That's actually I'm glad you brought that up. So our founder was a B-1 bomber pilot in the Air Force, and we have a big base here in South Dakota. And so he was stationed there and fell in love with it. It's very hilly here, lots of mountains, kind of like Colorado, but more sparsely populated, and wanted to make this his forever home. And so he took this passion that he had for aerospace, and he has a background in mathematics and software, and originally set out to find a better way to additively manufacture airplanes, which is really hard to do. So as he was trying to figure out how can I break into this industry, what he started to see is there's these super expensive printers, couple $100,000, and they're great, but they're totally out of reach for someone who's starting their business or as a mid-sized business. And then there's hobbyist equipment, which is great, but it doesn't give you the precision and quality that you need when you're trying to operate a business. So he decided, to Jill's point, I'm going to build my own, and it's going to fit that middle market need where it's high quality but also affordable with a fast return on that investment. And so he launched on Kickstarter, did 2 series of raises, actually delivered on time, which I think is something that less than like a third of all Kickstarters do. And from there, that was our first generation platform. We came up with another one. That's where we got connected with Jill actually in APMM, and that one is a little more user intensive, but good resolution still. And then in 2017, we came out with a platform, the Core series, which is all these parts I'm showing you on here, and that you never have to calibrate it. It happens once at the factory and never again. And it's a desktop unit, no additional ventilation or anything needed. It's really designed to be precise and fast. So you're printing, these parts, print in minutes. You can get a full model like this in under an hour, from print all the way through clean and cure. Because we were finding when we were talking with a lot of people, they're like, by the time I print a design, they already have another for me, because that's how fast we're trying to iterate, and we need a technology that can keep up. So that's the story of our founding. And we, we're in a university incubator space for a while. So that's why you can picture all that in about a quarter of the size, still shipping to 70 countries. And then, last year we were able to get this great new facility and expand.
How many people do you have working there?
Teresa's question. We're at about, I think, 35 full-time employees, and then interns. Interns are actually a huge core part of our program. We convert a lot of them into full-time employees, and it's a great way for them to get design experience, engineering experience, sales and marketing experience, and have a really good culture fit, and then come work for us full time. Did you have something, Bruce?
Yeah, I'm working on the newsletter for the APMM, and I'm trying to find out how our members are doing, or what our members are doing for COVID responses. And I'm wondering if B9 Creations made something or did something for that.
Yeah. Be happy to talk about that. Luckily we had already released a medical equipment compliant printer. So a lot of what happened with additive manufacturing, as I'm sure you guys are aware, is when the COVID-19 response was needed, people were just producing things, right? Masks and nasal swabs. And we really took the approach of wanting to do it in a medically compliant way. So partnering with hospitals, having a printer that's certified, having biocompatible materials, and a standard process, so that we were delivering to a real need that they were telling us about. So we did everything from nasal swabs for hospitals experiencing supply chain shortages and their testing supplies, to masks, and it's not just the medical community. What we really try to do too was work with businesses who needed to have that face-to-face interaction, like telecommunications, but didn't want to put any more burden on the hospital supply chain by getting masks from that source. So instead, work with us to 3D print them and then replace the carbon filter so the mask could be disinfected and reusable and last longer. So that in medical response. And then, you know, we also did things where companies that were shut down, we act as a logistics center. So we had a company who said, hey, can we just store things here and then ship them out as needed? Because we're unable to do so. To offering, you know, we upped our service bureau capacity short term for folks that couldn't access their printer and needed that help. And then we try to tap into the network of customers we have in all industries where if we can't help you, can I connect you with someone that can do that final processing or can cast these parts into metal and be kind of the connection network. So those were just some of the responses that we try to do and just really saying, what do you need and how can we help?
Thank you.
Yeah, of course.
Can you tell me, this is Charles, good to see you again.
Oh, good to see you too.
We were working with another SLA vendor and learning more about their flexible resins. And one of the things that we found out was that, and I'm going to get the terminology wrong here, but that you couldn't, it was skin sensitive. You couldn't continue to touch their silicone resin over a period of time. You know, it was really purely a prototype application for their soft resins, and it was not appropriate for any long-term use part or long-term touch part. Is your silicone different from that because it's black? Does it continue to degrade over time? Can you just tell me a little bit more about the,
Yeah,
if I wanted
absolutely.
to put short-run production soft parts?
Yep. So the color doesn't, I don't think the color will impact it too much. It should be fine for touching it like this. We go through a separate certification process if it's going to remain attached to the skin for long periods of time. So that's like taking this material through biocompatibility certification, which is more if you needed things, you know, because we do things like external enclosures for pacemakers where it has to remain against the skin for 30 days. So that's separate. And this material is going through that testing but hasn't. But if you just—
But you expect it to, you expect that material or some derivative of it to be usable.
Yes, and it's usable now in the sense that I prototype, so like this is a bike grip, so you're obviously going to touch that.
And would but you would feel comfortable putting that bike grip on your kid's bike and letting them ride it?
Yeah, completely.
Okay.
And it goes, you know, and leaching and curing and all that. It's just different. What I don't want to promise, because we're still going through testing, is if it was something that was going to be continuously in contact, and then that has to go through, you know, irritation and skin sensitization testing and all of that. So this is still in progress in terms of that, but we run our materials through that as well since we serve a medical division. Yeah, and if you want, you know, you have my email. If you decide you want a sample of this, I'll send you one. You know what I mean? Just one of these bike grips, and then you can see it. The cool thing is it has some of the differentiators in terms of this elastomer. It has a really fast response time, so it pops back out and still retains its shape, which was a requirement we got from a lot of customers, because other types you push it down and just hangs out there. And so that was really important that we do that. And then we did it in black because that's just a very common color for prototyping, but it's got pretty good resolution too. I mean, you can, I don't know if you can see that. You can see all of those little grips and our logo and stuff. So it still has that same type of high resolution.
Is that also printing at the 25 micron level?
Yep. So in the XY, because I think this one we did off of our machine. Everything in the XY on the XL printer will be finer than 25 microns, and then you can still pick your slice thickness.
Okay.
So you know if you want to go thinner, like this is 20 microns thin, you can still choose that as a variable length, but everything in the XY plane will be that.
One of the other things that we recently learned about was using alcohol-based dyes to color SLA parts, typically post-treatment, post-cure. Do you have white and clear resins that will take an alcohol-based dye? So I don't know for alcohol-based dye, because I'd have to go look, but I can tell you what people have used to dye. So we have a white biocompatible resin, and we have a medical customer who does that post-dye
it's called RIT dye, and I don't know if it's alcohol based, but it's basically you put it in water and you dip it and it colors it, and it colors it beautifully. And he's in a variety of colors, blue, yellow, etc. So I know that works. If you had like a specific one you're looking at, and I'll chase it down to you after this and see if that is alcohol based. That's just the only thing I'm unsure of, but I'll search that and get back to you on that.
Yeah, no, RIT is not, but it's less expensive actually than an alcohol-based dye. But
Okay, well, I know that one works because he's used it.
you use isopropyl as your rinse solvent.
We do.
So the idea is that you dye an isopropyl solution,
Oh,
and it
okay.
actually has better penetration than a surface dye like a RIT dye or something.
Oh,
like that.
okay. That makes complete sense. I mean, obviously, you know, this can withstand isopropyl alcohol because it's
Right.
what we clean things in. I just personally haven't run a dye through that process to let you know. But we do have, you know, all our materials are paintable, and I know that white takes dye really well.
Cool. Thank you.
Yeah. Yeah. And same with the, you know, the kids bike. If there's like, we'll take that offline. And if there's specific requirements, QA or regulatory, and you and I align on that, it's pretty easy for us to chase down because we have that whole material lab and regulatory in place to go figure out what's possible.
Okay.
Yeah.
Thanks.
Of course.
How long did it take to print the bicycle hand grip?
You know, this did not print in an hour. This took a couple hours because it's tall, and B, it's a super viscous material. So when you put, you know, I don't have a build table here, but when you put a build table into that resin, you have to wait so that it can clear out and then lift it. So I would, you know, this is not our fastest printing resin, so hours, you know, not an hour. But it's still faster than than most ways of being able to, find a flexible resin, whether you're doing normal production or additive. Yeah,
Oh,
you
yeah,
did.
can I
Please.
say, yeah, because I'm here as like a student, so it's quite like really interesting for me to realize there's different types of resin printers, because
Yeah.
it is the resin printer, the one that printed the bike handle, is it?
Yeah,
'Cause,
it
like,
is.
To me, while I was studying, the only resin printer that I ever used was SLA print, which prints solid, but I was actually quite surprised that it was really flexible. I was wondering if they have a different like curing process or cleaning process compared to like SLA, like a hard solid resin printers.
Yep. So it might be helpful to take a step back and share that we do DLP printing instead of SLA. So SLA, you know, rather than a laser that would trace your part and then color it in, for lack of a better metaphor, DLP is a pixel grid. Think like a TV or computer screen, and it turns the pixels on and off in an entire layer at a time. So when I'm printing this, it's printing an entire layer by turning those pixels on and off, which is why it's fast and high resolution. And your time doesn't increase when you add extra models to the build table. It only increases in vertical height. So I can have one of these or 10 of these, and it's going to take the same amount of time because of the way that technology works. And it's just an industrial light engine that does that. And so the printing process is the same whether I'm doing a flexible elastomer like this or a hard printer. You know, the cleaning and curing is also with the same platforms. It's just the timing that might change. So if I have a super viscous resin like this one, I'm going to need to clean it in that isopropyl alcohol for longer. So we have an automated unit where you take the build table out of the printer with the print attached, and you drop it onto a lid in an automated cleaning unit, and it will pump up isopropyl alcohol from the base and agitate it around your part for you. So it'll clean it and then drain it out, and then you can take that part and cure it in UV light. And we cure all of our parts in water in that UV light box. And the reason we do that is it's an oxygen inhibitor. So you actually cure a lot faster. So you're curing in minutes as well, not hours. So I can pop this in for 10 minutes, you know, and it'll be cured to its final mechanical properties without using heat because we use that water.
Okay. Oh, that's
does that answer your question?
Yeah, it does.
Okay.
Yeah, thank you.
Of course.
Can you talk a little bit about your software and software development, and particularly about the time it takes to set up a build? I mean, we still find, you know, regardless of the technology, whether it's a powder-based technology, there's significant learned knowledge and or learn skill to setting up a build. And particularly what we find is that if people aren't putting in enough time on the front end, adjusting their touch point size and these types of things. Is that still true with your software? I mean, and where is that progressing? How do you, with your software, there's sort of benchmarks and tools to tell you you've got a good build and that kind of stuff?
Yeah, that's a great question. It's like there's two dirty secrets of 3D printing, and it's what you do after it comes out of the printer and what you do before it comes in. And those can be sometimes your biggest time sucks. So our new software, you know, we have auto support like a lot of other ones do. I won't ever give you the impression that that's 100% foolproof, because that's not realistic. But the new software that we had at least tries to look at the geometry of your part and lay it out in a way where you have, you know, the least unsupported geometry. So you require the least amount of supports, and it will highlight all those unsupported areas in like a yellow highlight that then turns to green when you add a support with a radius that shows you that part will print. So you have some intelligence going in if you're going to go in manually. We also on the auto support side have part templates, both that we preset and that you can customize. So we find a lot like in, I don't know, maybe this is a good example, but we find a lot where if I'm making minor tweaks to this part, if I lay it out and support it once, you can save that and it'll apply that intelligence the next time you put in that part. So you're not starting from scratch.
Including the part rotation?
Yeah, and it'll try to support it that way. And so you can save it as part of your part library. Yeah, which helps. It helps. And it has. And so part of that, you know, back to that, like we like to collaborate with our customers to develop better products. We put it out there in this new software we have, but we are actively seeking feedback. So we're in a Pioneer Edition is what we call it, so that we can get all of that, say, yes, it's working, no, it's not, yes, it would if it could do A, B, and C, and then incorporate that into our development cycle. The other thing we try to do to eliminate some of that step is support mirroring. So if you have a symmetrical part, you know, you can slice it on any plane you want and support half of it and it'll automatically populate the other half. And those are just things that we're trying to design to reduce that lift and make it a little bit more obvious. And then part of what we do as well when we sell anyone a printer is we have factory startup assistance. So we'll take a real print from you, get you on a Zoom like this, and walk you through the software with your part. So A, you leave with your part oriented and supported and you know how to do it. And then we have additional support training. And you can call us at any time and say, hey, what's up with this?
So you have support.
We have support. Mm-hmm.
What's your typical and what's your minimum touch point size?
You know, it gets pretty hairy. So something, I wish I had some to show you. You can go down pretty far, you know, because you can basically have thin walls that are 50 microns, 100 microns. You can have supports that are about that as well. Obviously, something like this, we even supported this, if you can believe that, and then went under a microscope to clip it. So you can get pretty small touch points and then adjust the penetration into the model, as well as the tip size. You can adjust your shaft and then the base as well. So it's fairly customizable in terms of what you're looking at, down to that, you know, 100 micron, 50 micron type chip. Yeah.
Thank you.
Of course, yeah. I mean, I've even had, you know, we have a customer and they have a bunch of printers, all different kinds, and he has one of ours. And sometimes he'll still get a project and call us, and he'll be like, I don't want to figure this out. Like, can you just support this for me and send it back? So, you know, I get it.
Do you do that free or?
It depends on the volume. Like I can't commit that team to doing that, you know, for 50 parts, or they won't let me on any more Zoom calls. But yeah, we try to work with our customers. Because I say, like,
I'm gonna buy your machine because I get a free person with it.
Yeah, exactly. I didn't know this came with 1 FTE. I would have bought it a lot sooner.
Yeah.
But yeah, we do try to do a lot of
offer, though. That's
really nice. and on the front end too, you know, not just on the support. If people need it, we also try to offer a service that's just designed for additive. Like, hey, normally I tool up for this, and this is what the part looks like, and it's optimized for that production method. what would you change if you were going to do this additively? And so we offer that service as well, because sometimes it's just helpful to get that perspective. I was working with a customer today where their part was in 2 pieces because that was easier for the tool. But you don't need to do that additively, and it would save them a ton of time, you know, and allow them to do lower minimum order quantities and release products faster. So even sometimes that's a helpful service before you even get it in the software, is to say, what tweaks would I make that this is better, faster, easier, etc.
I should compliment their support staff is pretty good, Charles. They've gotten me out of some really nasty pickles and dealt with some of my serious grumpies, and they still like me. So,
and she still likes us.
And we should probably just leave it at that instead of telling the whole backstory, right?
Yeah, but you call a real personal answer, I can tell you that. So we'll help figure out your problem. Mm-hmm.
I have a question.
Yeah.
So with some types of printers, whether they be the powder bed or the multi-jet fusion, you can basically stack parts all the way up through your print bed. But obviously with an SLA, you'd have to have supports from part to part to part. Would you guys normally recommend just stacking a bunch of short parts out flat and then just redoing the print with multiple trays? Or would you suggest it's worth it time-wise to stack them and build supports around everything? Because obviously there'd be a cleanup with snipping off all the supports that are stacking on top of the part as well.
Right. Yeah, that's a great question. I'll tell you what I recommend, and then I do have customers who do the stacking with lattice supports because they want that volume and they see that. But frankly, our printer's so fast that a lot of times it's better if you just rack it up, multiply it on a tray, and iterate quickly versus trying to stack it and take that longer print time, kind of that single piece flow idea. I'm not going to do these batch. I can actually get higher yield faster by doing it where you're putting 6 flat on a tray and then printing that. But I do have customers who they like to do that, where they stack their parts on top of each other. It's just not necessarily, in my experience so far, a value add, because of the way the technology is designed to be fast. If we had a bigger print envelope, maybe that would take forever anyway to get one done, so I might as well maximize it. But that's just not the end of the spectrum that our technology plays on. So that's a great question, though.
That brings me up to another question. What is the limiting factor on your X and Y dimensions? i.e., could you build a printer that instead of being tall is really wide and shallow, so you only get maybe 50 to 80 millimeters of Z height, but you could theoretically put hundreds of parts in the X and Y because you have so much space in that direction?
Mm-hmm. So the challenge always with going wider is this example of like a flashlight next to a wall. The reason it's so sharp when it's close and then it blurs as it gets further away, it's the same kind of parallel, if you will, to our technology. So you can definitely go wider in your XY all day long, but one of 2 things happens. You either have to start to figure out, how do I not lose resolution? Because that's what's going to happen even the wider you get, even if you don't go tall. And then if I don't want to, sometimes it can be quite expensive to find the light engine technology that's able to have that output over that wide plane. And so that's why part of what we're trying to do with this is we didn't go immediately to a 12 by 12 by 12 platform. We went double what our biggest one was and still kept that effective resolution better than what you would be able to buy with our previous technology off the shelf. So going tall can be a little bit easier because that won't impact resolution the same way. So that's kind of the philosophy we've taken. So we're definitely already, we're always in development building larger print envelopes, but we're trying to do it in a way that still stays true to that fast, high resolution DNA, even as you scale. So that's kind of one of the challenges there.
Yeah, makes sense. Cool.
Mm-hmm. Yeah.
I have a question. So I work with a company that makes like silicones for mold making and casting.
Cool.
And a lot of the times with the like SLA or alcohol, like the light cured resins, people have trouble getting platinum cured silicones to cure against them. is there another curative like liquid that you could use other than alcohol that wouldn't cause problems for platinum cured silicones that you know of?
Honestly, I don't. And, you know, if you ping Jill, you can get my email after too. That's probably a better question for our chemist, our material chemist, or our product manager, because they're a little bit more in the weeds in terms of all of that entails. I personally don't, but I'll see if I can get you an answer. I'd be happy to, even if it's they don't know either.
For sure. Thank you. I'd appreciate it.
Yeah. Mm-hmm.
Yeah, that's a really good question, and I'm glad you brought it up, Michael. I was just kind of thinking and pondering, and I guess I've only ever tried tin-based silicones against the B9 stuff I've cast.
Mm-hmm.
I use cooked organic black rubber molds against it almost weekly, and I mean just all day long I can pull white metal pewter molds off of this stuff.
Mm-hmm.
But I haven't jumped up to the platinum.
Yeah, I don't know. I don't know either. You know, most of my casting knowledge is actually in the jewelry industry, so I can tell you.
Is there a reason?
There.
Is there a definitive reason for trying to use a platinum silicone instead of a tin silicone?
A lot of people, they're trying to go like straight to production molds. So if they use the tin cured silicone, they'll have to have that as like a stepping stone to the platinum.
Just because they don't get the longevity out of the tin.
Yeah, and then also the tins have more shrinkage than platinums do. So the kind of the quality of the part you're getting could be a little altered depending on how important like accuracy is.
What kind of quantities do you know, to use a mold versus direct printing, what kind of quantities are you talking about production wise that would lead you down that direction?
A lot of the times, so it's either hobbyists. There's a lot of people making dice now where they'll cast like resin dice, and it's not that the printer can't print the dice for them, it's just that they want different effects for their dice, like they're going to add things to it to make it look cooler. And then there's a lot of people in the miniatures industry who are using silicone molds to actually produce like hundreds of castings from a mold, and they have a full production line kind of setup going on.
Let me just interject. Michael, you're Reynolds Advanced Materials, right?
Yes, yeah, I'm with Reynolds.
Danny, they're a huge company. What do you have? 13 facilities?
Yeah, around the U.S.
So his experience is it'd be worth answering the question for a lot of, because his outreach is pretty enormous actually.
For sure.
Yeah. Sorry, go ahead.
Oh yeah, I was just saying that it's become more and more of a thing because printers are becoming more readily available for like hobbyists, but also, and then it's just affecting a lot of industries that are making molds with our materials. And it's interesting because like you get mixed results. It's different for every part depending on how cured it is. But I think what it mainly comes down to is some of that alcohol will still be exuding out of the print.
Yeah,
so it will,
makes sense.
Some prints will work, some prints won't. And there are tactics you can do to kind of defend against it, but they're none of them foolproof yet.
Okay, yeah, no, that'd be great. And obviously, even our printer can't help with any type of effects or texturing you'd want. I'm just curious about quantity because a lot of times people think this is good for tens or hundreds, but I mean, we're doing thousands of part runs easy on a printer. So I'd say if it's under, you know, maybe 10,000 under.
I would have to jump in and say that Michael's typical customer would be like a lot of different products, not necessarily a lot of big volume production.
The same.
Forgive me if I'm incorrect on that, but they have a very broad range of material availability with their silicones and with their urethane resins.
Gotcha.
And so making a printer, it may not be worth doing a production run on something when they can do a resin run.
Do it this way. Yeah, cool. Well, yeah, I'll chase it down for you, and I'll I don't know if Jill, if you can connect.
Yeah,
us.
I can make a note and hook the two of you up.
Perfect. Yeah, cool.
Danny, would you comment a little bit more about your production run versus the mold run? What is your what would you break it out to? I mean, 200, 500. What makes more sense in 3D printing than a mold?
So, I mean, to be honest with you, I have a customer in the UK who does models, and they're doing, 3,000 part runs for wholesale orders additively with 3D printing and not even bothering to tool up. And we work with a lot of companies too, where We try to scope pilot runs, so it's like no sweat to do a couple thousand, and then as you ramp up from there, you either need a print farm or it might make sense to mold. But frankly, if you're not in the millions or the tens of thousands up, additive is not a bad solution, because you can go fast, you can go a lot of different geometry, but it really depends on the part itself, what you're looking for. But we have a lot of customers that are doing thousands of parts for a production run additively versus trying to go to tooling at that point.
I think also with additive, you don't have to have consistent wall thickness, correct?
Yeah, there's a lot of things that injection molding requires, or other production that no consistent wall thickness. You don't see those seam lines at all. Obviously, the trade-off is you got to be cognizant of where you're putting supports, but things that you would have to do in two parts because they're just hard to get out of a mold, you can do all in one additively and not have to worry about that. Complicated geometries like you're talking about, you don't have to have uniform wall thicknesses. You can have quite thin walls. So it just depends on what you're doing, but there's some advantages to, plus once you have a tool, you have a tool, right? And you got to pay if you want to go make a tweak. So sometimes folks like to use it additively, that kind of bridge to production in the thousands. They might still eventually go, cut steel or aluminum or whatever and do a tool, but it's a good way to get market feedback before you go make that investment and then tweak along the way. Did you have something, Bruce? I thought I heard you talking, but.
Yeah, I was just saying that the material properties are the big roadblock for additive, in my opinion. You need to have, you've addressed a lot of biocompliant and that kind of thing, but sometimes it has to be machined as opposed to molded because of the material properties. Mm-hmm. So that's the last hurdle, I think, for additive manufacturing.
Oh, 100% agree. Because people don't care about the printer, they care what comes off of it. And so, it's not even just regulatory, because obviously aerospace and medical and have all of those, but also just, I need something that isn't like nylon, I need nylon, or not like ABS, I need ABS. And so that's a huge part of it too, knowing what material that you're getting, and do I have something that meets that needs? Temperature resistance, chemical resistance, is it going into assemblies? We put things in where, so your resin doesn't degrade over time, understanding how does UV blockers affect it, even post-printing. So yeah, I just, amening what you said, you really need to be cognizant of what does this in-use environment look like, so that I can see if it would work additively or if I need to use the real material.
Good question. Have you guys done any studies on degradation over time on the more conventional materials?
On ours, like on our
materials? like the old black, cherry, red resins.
Yeah, I would say not super probably as scientific maybe as you would if we sent it out to third party.
I've had your machine for 4.5 years. The stuff it's sitting on my desk hasn't fallen apart yet. Exactly. Is there any kind of expectation?
Yeah, so what we try to do when we release material is just accelerate it. So we'll just cure it under way intense UV light to simulate like what does it look like after 6 months in a shortened time frame.
Yep.
And make sure that it doesn't, obviously if you hit it with UV light, you might see some changes over time, but at least to make sure it's not going to fall apart or degrade, but just make sure what do the material properties look like? Because something that's flexible, you don't want it to become too brittle over time as it's hit with UV light. So there is definitely a change if you left this outside for 3 years. But before we launch material, we do a test where we accelerate what UV penetration would look like, so that we can get an idea of, do we need to tell anyone what this is going to happen over time, or will it be fine? But I have parts that are years old, as long as I've been working at B9 too, and they're fine. They're over here chilling on the desk. I still take them to trade shows. So yeah.
I'll ask for Charles, what about clear parts staying clear?
Yeah, I tell you what, that is a challenge. It's a challenge even to print clear parts that are clear, because when you think about, I want to shoot light through a material and have it cure, well, clear just diffracts that all over the place. And so we don't currently have any clear materials that are commercially available. I'll just say that out there. Our platform's open to third-party materials, so you can certainly use other resins in there as well. We do have some of those, in our product pipeline, and have found There are different ways to do it where either you can look at a material that prints clear and then make sure it doesn't cure yellow, or even sometimes there's materials that do the reverse where potentially they, you know, print yellow but could cure clear, and all of that is in the chemical composition. So there are some interesting things out there, but nothing that we have commercially available yet. But that's a challenge. Same with our white biocompatible material. You don't want all that Z bleed, but what you're getting is you shoot light up through a clearer white refracting type substance, and you got to make sure your dimensional tolerances stay good. And so that's a challenge too, not just the yellowing, but making sure that that you print what your CAD file said you were going to print every time. But it's another challenge too. So I work at B9 Creations, and we do high precision DLP printing. So when I say high precision, this piece is a transformer and part of a catheter, and this is what it looks like blown up. So it's super, super tiny. Your patterns probably won't work, and any jig and fixture that can fit in this build envelope is about what we do on our biggest printer with our new XL. So we were founded by a B-1 bomber pilot who was stationed here in South Dakota, where I live, in the Black Hills near Mount Rushmore. Fell in love with the area, launched the company on Kickstarter, trying to find a solution between a super expensive 3D printer that was out of the range of most businesses and a hobbyist printer that was really more designed for a consumer market. So he launched something right in the middle that could deliver a good payback for small and medium-sized businesses and give them the quality that they needed. Since then, we're now in about 70 countries around the world. We're in a variety of markets. Model making is a big one for us, the whole industrial space, universities and research, jewelry. We're also in medical as well. And then we have a dental partner who OEMs our printer. So it goes out with their name on it, and they serve that market. But what questions do you all have?
I'll jump in. Is the slate ever going to be, is the slate at all reverse compatible with the earlier machines, or is it strictly a go forward? Why is it? I suspect not. Why?
Yeah, so because of the way you develop material settings, it's not just the chemistry of the material, but it's the mechanical movements of the machine. And so our first generation technology, because it, you know, it has a sweeper and it's a totally different mechanical setup than our latest generation that I showed in there, the settings wouldn't go one for one. I do have, for your particular one, I do have a starting point. So all of our platforms open to third-party materials. So you could treat this as a third-party material with the B9 Creator first generation. And I could send you over a starting point there. But that's why from once we launch that core series, all those materials move forward because they're formulated with the way, you know, how fast does a build table rise up and down? How long does it wait to settle at the bottom before lifting up again? All of those kinds of considerations go into helping this resin print the way that its chemical formulation is designed it to do.
Okay. So,
yeah.
I'll jump in. Could you describe the process a little bit further? You mentioned a light source, and is it liquid or powder? Go ahead.
Yep, so it's a liquid photopolymer resin, and that's all we do is plastics, liquid plastics. So no metal. We do have a plastic that you can, you know, burn out, basically create a reverse mold and fill with metal, which is what we do a lot in jewelry. So what it is it's, the reason it's so precise is if you think about it like a flashlight close to a wall, and I don't know are you pretty familiar with SLA generally or what? So unlike SLA, because it's a pixel grid and not a laser, you're not having to trace each model and then color it in. So it gives you a couple things. It gives you resolution as fine as some magic we do with the pixel size itself so that you're getting finer than 25 microns or finer than 15 microns. And it also means that whether you have one model or 10 on a build table, because you're not tracing it, you're turning on the pixels all at once. It will take the same amount of time. So you can have 1 or 10, it'll take the same amount of time. The only thing that increases time is vertical height because it's building that layer by layer upside down. So it's sometimes the struggle when you go bigger because people are always like, why don't you print bigger? When you take a flashlight close to the wall, it has very crisp edges. The further you pull that back, the blurrier the edges get. DLP is very similar the same way when you remove that light source down in order to have it go across a wider area. So you either lose some of that resolution, or it's incredibly expensive type of light engine that has the power to do that over the full build plane versus lasers where you're going in on each model. Does that answer some of your questions?
Yeah, I think so. Can you share what the light source is? In other words, how are you getting those pixels?
It's just, so the light source is just a high definition light engine, and it's also powered with a little DLP chip. And the pixels are simply so there's I wish, I don't have a vat, I should have brought one, but it's just a vat with a window, and you set it above a matching glass top on the printer. So this light source is below, it shines up through this window and then up through this vat, and we actually do contactless 3D printing. So when you lower your build table, it's an oxygenated vat, and that helps mitigate your release forces, so you're able to lift up quickly and without losing detail, without ever actually having the build table touch the film. And so you're doing those pixels where the software is slicing each layer, so it knows here's the pixels to turn on here and here and here and here and here, all the way down. And so that software is telling the printer what to print at each slide, and then because nothing touches each other, it's able to do that fast. Does that make sense? Does that answer your question, Bruce? Does that make sense?
Yeah, that's very good. It's a high definition TV kind of screen.
Yes. Think about it like a high definition TV or your computer screen. It's the same concept. It's, yeah, pixels.
Yeah, and your claim to fame is speed and detail, it sounds like.
Yep. Yeah. And, you know, we're still a small enough company, like you literally saw the whole thing, that it's kind of what I describe as our competitive advantage, because we're not big. I don't have $1 million budget to go sell or market or do a ton of R&D. So we try very, very hard to develop things that customers ask for and with their input. So this slate material I was talking about, we actually had a model maker who was using a different resin of ours and putting in pigment and doing all of this tweaking to settings. And the result came out so dang good that we said we should commercialize this idea and actually bring something to market that delivers what you're not finding anywhere else. So we do a lot of that. You know, Jill had one of our first creators, and the leap from those technologies is that was a projector. So rather than a high definition light engine, it was just kind of a modified off the shelf projector. So you had to do a lot of calibrations. Is my, you know, build table flat? Is my vat flat? Have I focused the light? And so we got some customer input that said, man, I mean, 3D printing's cool, but I have a day job and I can't be an expert in this. I want to push a button and my part comes out. That's what I care about. So that shift we made was based on that feedback as well. So these never need to be calibrated once they leave the factory. You know, on our core series, you print on that vat and it lasts if you take care of it. So I'd say that's the third, if you will. Speed, you know, precision or accuracy, and then being super tight knit with what customers are asking us for, driving our product development versus the other way around.
Mm-hmm. So you mentioned dental and medical. Is that inpatient products that you're creating?
So right now, all of our, here's one you can see, all of our biocompatible materials are for external skin contact only. And it actually, some model makers approach us for that too, because when you think about toys or figurines going in kids' mouths or whatever, you want to make sure you don't have any of that irritation and sensitivity. So right now, everything that's commercially available is external skin contact only for up to 30 days, like insulin pump enclosures or pacemaker enclosures, you know, wearables, watches. We have some other materials that are in development that could go further in that regulatory, but what we've seen so far is that they're either prototyping medical devices, that's our biggest market, and we've just now started to go in the more clinical side. So we partnered with hospitals, obviously during COVID, to do nasal swabs and masks, but we haven't done anything that is implantable, short-term or long-term yet.
I own 2 of their machines. I have the older version, which had to be calibrated based on the size. The higher resolution prints gave me a smaller build envelope. The larger prints required a different set of calibrations. I ended up with 2 of their machines because it takes probably 10 minutes to reset and recalibrate the machine. And then theoretically, you should really test them to make sure that they're running right. So it was just easier for me to have 2 of their machines sitting in here side by side. It's a real treat because I just go over and print it and I don't have to fuss with it. I mean, they are pretty amazing in terms of resolution and quality. I came at 3D printing from a CNC machining background, and nothing was ever good enough. And then I ran into one of these machines and it just had a meltdown. I mean, I decided to buy it within 6 hours of seeing it. And I mean, it was, and it has performed. In my model shop, I'm not necessarily printing finished product, but in my model shop, I'll print and throw it in a spin cast mold because a lot of times I have to output a metal model, or I'll print in another material and send it off and have it lost wax cast into silver or gold directly. It's still 3D printing. You still have build layers, but I mean, you almost just blow on them and they go away. It truly is an amazing amount of resolution. And the other thing that's really pretty fascinating for me is my parts usually cost me under $1 to print. So if I just, if I need a quick fixture, a quick jig, a stirring stick to stir some resin, and anything special like that, I just knock it out. And I mean, 30 minutes, 45 minutes, I have the part in my hands that I need, and I can evaluate it, have a look at it. I use it a lot for 3D sketching. Instead of giving a client a drawing from 15 different views or a hotshot little rendering, I just print the thing off and mail it to them and say, hey, do you like this or do you not like this? Because it's really affordable. It's amazing. On the new machines, my machine has been discontinued, but what is the print price on the new machines?
For the printer itself?
Are the prints still as inexpensive?
Yep. So the material's still the same cost.
So
your print, yep. So it's still the same price. So most parts are sub $1. That little guy showed you is like a fraction of a penny, and done in about 5 minutes. But that's a great point, Jill, because we do have a lot of customers that use it as a sales tool, as a customer-facing tool, not just a production tool, to be able to verify a design or close a deal. People like to hold tangible things, and it's durable enough you can ship it all over and it doesn't break. Yeah, so that's fantastic.
Danny, you might want to let them know what is your machine price range?
So the core series, which is a 530, 550, and that's about 15 micron effective resolution and sub 25. It's a little smaller than this. It's the same height, but it goes to about here. Those are $10,000. The XL machine, we're in pre-orders right now, and those are just under $13,000 for the industrial version of this. And then materials are all under $200 minus the biocompatible, under $200 for a kilogram. In these tiny parts, I mean, something the size of a ring, I could get like 600 to 800 prints out of a bottle. So it lasts you quite a while to be able to do that cost effectively.
What distinguishes you from other DLP printers?
Yeah, I think, a couple things. So one, some of it's just the technical. So the speed is there. Also, a lot of other machines require calibrations to them as well, or their vats are consumable over time. So they start to wear out pretty quickly, and then you need to replace them and have that be an ongoing operating cost. And so the way we've done our technology is part of this new upgrade. We've also upgraded the software. And so a lot of times you either pick surface finish or accuracy, because your surface finish by its nature blurs all of the edges, and that means you start to lose dimensional accuracy and resolution. And so we've made that where it's not a choice. It's through a proprietary technology on the printer and the software that our founder developed. So when we basically, because we're owned by a bunch of engineers, we just do what we say we're going to do. And so it's the high resolution, that can be pretty equivalent across printers, but it's quite a bit more expensive. So if you're thinking like a competitor is a EnvisionTEC CDLM, it's the same type of technology that we use, but it's $30,000. So you can get the same resolution and speed, but not at the price point that we choose to offer, so we can serve small and medium-sized businesses. Another big differentiator is our material suite. So when we have like a nylon 6 like resin, we make sure it actually hits the specs within the range of an injection molded nylon 6. So it's not an approximation, it falls within the range of whatever material we're simulating. Kind of the same thing, this flexible polyurethane elastomer, this silicone-like material. And then the other thing I would just say is the customer experience. You know, you call and a real person picks up. You can email me directly, anyone in the company really, and we'll make sure your problems get resolved. And we also make sure every time we come up with an upgrade, we try really hard as much as we can to see what can we retroactively apply. You know, can I give Jill a starting point for settings on a material that doesn't work for the creator? When we upgraded to this new XL, we took the software powerhouse of that, and we said, if you have a core series, you can get this. You can get better resolution, you can get faster, you know, slicing times, you can get better surface finish, better accuracy for a couple $100. So you don't have to always upgrade to a new equipment to get the benefits of the latest and greatest technology. And that's not something you find everywhere else either. Just companies are big and it's hard sometimes to get a hold of a person, or they know you by name. So that might be a good segue. Maybe I'll answer your question, Jim, if that's okay on this platform. Are you cool with that? Okay. So he emailed me and he was asking about, you know, a business model where you could use your printer to serve multiple customers, giving them on-demand parts. We have a lot of folks, some are model makers, some are service bureaus, but we have a lot of people who do both. So they may have bought a printer for their own production needs, but they take on different contract work for various customers to provide their parts on demand, and they pay off their printer pretty dang quick doing that. So that's definitely a viable business model and a pretty common one actually. And same with us, our primary focus is a printer manufacturer, but we have a service bureau arm. So if someone says, hey, I can't afford this capital expense right now, or really I only need 5 parts, or, you know, sometimes we get orders for thousands of parts run, we do that as well if that's a need that anyone has, instead of just bringing the technology in-house. And then you also asked about the hobby market. So by hobby market, you know, do you mean I am running a business trying to sell these models, or is this I am just a person, an individual printing them for my own use?
At both.
Okay. So the, you know, the business side of it, absolutely think it's a good fit for that. We are, almost all of our customers are B2B, it's business to business, and that's why we have priced it the way we did. It's why we have financing options. It's why we keep the consumables where we do, so that you can print that affordably. For a consumer, it might not be the best entry-level machine. It really depends on what you're looking for. If you need high precision, you're gonna have to probably spend accordingly, but there are other technologies that aren't quite as expensive that I think might be a better entry level if it's just I'm printing for fun in my house versus I need this as to be able to make revenue.
Gotcha.
Okay. Danny, we've got a chatted question about how easy are the supports to clean up.
Yeah. So they're not that bad. You know, you can't even really see the scarring on here. Those are kind of the 2 hidden costs of 3D printing, is how long is it going to take me to prep this model before I print it? And then what does it look like when it comes off the machine? So these snap off. You can just snap them with your fingers, a material like this. We include things in the printer, little clippers and tweezers, so that you have everything you need to remove supports. It's pretty easy. It doesn't take that long. I am not even close to an engineer and I can remove it. And then we also have built some intelligence into the print preparation software. So if I brought in a part, it's going to try to orient it in a way where you have the least amount of unsupported area. So from the get-go, you're already using less supports, or it's trying to optimize for you using the least amount of supports. But you know, this printed straight to the build table. These had some under here, so you can see what the support scarring looks like. It's pretty minimal, and they're pretty easy just to pop off. And I usually do it after printing, and after cleaning before I cure it, so they're still kind of soft, versus in its final cured state, those are a little harder, and sometimes it leaves less of that scarring if you get it when it's soft. But pretty easy.
Let me jump in if I can. Is the support material feels about the same on the gray as it does in the older machines, right?
Yeah, your gray might be a little tougher, but negligible.
Okay. Dawn, when I'm doing them, I do a partial clip and then I cure. It's like a 4/0 file. I mean, they just file right off. It's like filing a soft plastic or a soft urethane. They're not gummy. They powder off more than anything. So it's 320 sandpaper or like a 4/0 file gets it.
And you can usually, you know, when I talk cleaning and curing, you can clean a part for 10 minutes, you know, 20 minutes maybe. And you can cure a small thing like this in 5 to 10 minutes, a big thing maybe 20 minutes. So it's not like it's taking hours after it prints to be able to get it to its final use state either.
I want to toss another one out. I've actually done a couple of kind of odd things. I can actually take their resin and use a paintbrush or a Q-tip and wipe it across a cured print and then re-cure it, which will help with the surface smoothing. I do that fairly often. You can also actually put this on a buffing wheel and polish it if you really want to, if you really need that sort of a surface.
Yeah, and they're all paintable as well.
Yeah.
So
I've
if
done that
you,
as well.
you know, want to paint them, it's pretty easy to do it. I'll show you another one too. So this is some examples. So you can kind of see what it looks like. This is not processed at all. I mean, it's cleaned and cured. So it gives you an idea of kind of what that surface finish looks like. It's pretty smooth. You know, jewelry is a huge market of ours as well. And so if it wasn't, I'd hear about it. So we tried pretty hard at least to make it where it mimics injection molded parts when you get it off, just with the finish, because in a lot of cases, that's what folks are trying to simulate. You know, they want it to look like something, whether they're showing a customer, so it's a real representation, or they're, you know, getting market feedback or trying to run it through their development cycle so that they can move forward.
Danny, if I was interested in finding out more about your Service Bureau projects, would I contact you or?
Yeah, you can email. Yeah, that's a good start. You can email me, and my email is, I'll put it in the chat here too. It's just Danny, so if anyone needs it, DannyMason@b9c.com. And then we actually have a little page where you can just upload your files directly, and we'll talk with you about it. You know, what's critical on the dimensions, what material requirements do you have? We'll work collaboratively and then see, you know, if it makes sense and how you want to move forward. But shoot me a note and I'll get you in touch with the sample experts on the back end.
The one product that you talked about that was similar to nylon, so a nylon model that I 3D, I can drop that on a concrete and it won't break. Is that your material does the same thing?
Yeah, I mean, I've dropped plenty and it hasn't broken. It's a pretty tough material. It depends on your part. I would want to see like the geometry of your part, you know? I mean, dropping this on concrete and dropping this on concrete are different. But yeah, whatever functional requirements you need that part to have, they'll talk through that with you. And they'll tell you like, yep, not a problem, or, oh, you might want to tweak this part of the design or orientation to be able to get you where you need to go. Or they'll be honest with you if that's not the case. So it'll be like a little design review with the engineers.
Great.
Yeah, absolutely.
I have a slightly different background. I was in model making for many years, and then I went into education. And so in education, I had to track all the different rapid prototyping processes. It's kind of interesting. The first time I heard of rapid prototyping, 1983. A salesman for the industrial design firm I was in their model shop came in and said, oh, all you model makers, you're going to be replaced. They got the new machine, it's got a liquid in it and they have lasers on it, and it makes the model for you.
You're like,
Of course, he was full of it. And there are makers now than there were in 1983. And we have cooler machines to work with. And so watching, there were processes that involved paper, processes that involved powder. And it's been interesting to me to see all the different processes that have come out over time and how the prices dropped through the floor.
Absolutely. And you know, back to that, if I designed something in CAD and printed it, it'd still be just a block of junk. So don't worry, getting replaced, but I always make it analogous to building a house. People are like, well, why doesn't this do everything? You're like, because you don't build a house with a hammer. Like you have to back up with a whole thing of tools. And 3D printing is just like anything. It's like CNC milling or, you know, whatever, hand carving. It's just a mechanism to make things. So yeah, I think that's funny too. It's like people think it's a little bit of a magic wand, and it's cool. Trust me, I love going to work every day, but it's just a production method, you know, and you're right. Not just the cost, the capability, but I think you had all this excitement, and then it was like a trough of disillusionment, you know, and now you're back on the upswing where you're seeing, okay, here's how I would use this today.
It's another tool in the toolbox.
Exactly. Yeah.
And I would always tell the students, don't line up to use the laser. What kind of part do you need? Oh, I just cut it out of the bandsaw.
Yeah, I thought that too. You know, they're like, we should 3D print these, you know, plastic acrylic shields. I'm like, no, you should not. That's a terrible use of that technology. Like, there are things it's good for, and there are things that it's better and cheaper and faster to produce other ways. So yeah, I can appreciate that. Oh, and Stuart, cool, I got your question. You use SketchUp. So we just accept STL file formats. So if you export in an STL, which most CAD programs use, and SketchUp, I can verify. Well, if you export in an STL, that's exactly what our software will take in that STL, and that's where you orient it on your build table, however you need it, and then you just kick it over to the printer.
Let me interject. The thing you have to watch, Stuart, is that you have forms interconnected. The printer is very sensitive, so if you have, for example, if you were doing a house in SketchUp and you didn't connect the two walls at the corner and there was a bit of a gap, their machine will detect that gap and give you unconnected components. So are you a railroader? No, okay. So you just be cautious of that. Still, I will accidentally skip a layer or not check something or have a little bit of a gap on my printer, and I go over to pull it off the printer and I have layers floating in my goo vat. And it's, you know, it was my mistake. It was my mistake. I neglected to properly seal the two parts together. So that's the only thing you have to be conscious of.
Yeah, that's great. And so in our new software, something else we do now is if there's like, so not a disconnected part, but a hole or something in your CAD file, like a mesh that's not sealed, it'll repair it for you so that you're getting a watertight model in. And then, yeah, you got to make sure things are supported, but our new software, and if you guys are interested in a demo or something later, email me and I'll send it to you. It highlights all of that in bright yellow. And so even before you get to the slicing, it'll turn it green as you're adding supports if the area around it is fully supported. So it's back to that, because even if it is self-inflicted, it's a frustrating thing when you go get your print off that table and you're like, dang it. Yeah, so hopefully that'll help mitigate some of that too. Thomas, are you using additive at all, 3D printing, or is it a curiosity, or what's your experience?
Well, here at Schmidt, we have an SLA printer, an FDM printer. We use our printers primarily for making master patterns that we then use to make silicone molds. But I think the footprint of what you have doesn't quite match most of the stuff that we do. But I'd just be curious for like the smaller pieces that we do end up making, like what would be the comparable like time frame? I mean, because yeah, there's the print time and then it's got to cure for like an hour in our UV oven, but you said like 10-15 minutes. So
yeah, it's pretty. If you have in that email, if you have a part you just want to see, like how long would this take to print and finish and kind of do it apples to apples. We have some folks that are doing industrial casting, like other foundries and patterns, but it's within this build envelope, but they're doing it successfully. So I'd be happy if you just wanted to know what does it look like, so you can compare process to process and see if it would make sense.
I'm curious, that piece that you're holding up,
this lattice?
Yeah, the lattice one. How long did that take to print?
So something that's this tall, it is like about 2 hours. Something this is under, can be under an hour, like this height. And then, this is a symbol, so it prints in 2 pieces. And then it's material dependent. So like Jill mentioned it, we have a gray rapid prototyping resin, and that hammers out small models in like 12 minutes. But that's designed to do that. If you needed something super fine detailed, that's where your time would go up. So, but all in all, smallish models, you can do about an hour or an hour and a half. Tall models plan on a couple hours for that. But
what is the build layer height?
So they're variable, so you can select it. So we have, if you want to, and it's material dependent too. So like in this rugged material, this nylon material, we have it at about 80. You can pick 80 microns or 50 microns, whereas something that's made for high detail, you can pick 20 microns or 50 for your slice thickness. So, and we also have that ability, because our printers are open, you can change the slice thickness, but we've already optimized it either for speed, a recommended baseline, or detail, taking into account this is a super viscous material, so it actually does better detail at thicker slices, or like a rapid one where you just want it all thicker because your goal is speed. I know that's kind of a squishy answer, but basically anywhere from that 20 up to 120 is the range of the slice thicknesses you can select.
Okay, forgive me, I'm not familiar with micron sizing.
Yeah.
So I know, like, if we have a part that has text on it or something, or a wall that gets close to 20 thou, it just won't build without possibly being partly there, not existent.
So
what is like 20 thou compared to microns?
So that would be just fine. So to give you an idea, it's like, so 20 microns is 0.02 millimeters. Go ahead, Jill.
I was going to say, I just, for really rough figure, and I'd go about, I just lost it. Sorry, guys. 1,000 is 25 microns.
Yeah.
Is the way I calculate it.
And
you really lose fast on the run calculations.
And you would have that in your XY. So
you can print 0.5 millimeter walls all day long without even thinking twice.
Easy. Yeah, easy. I don't know if I have.
And this is like an order of magnitude finer than the FDM or SLA's world. I mean, you're looking at 2 thou layer is 50 microns. So
yeah, and you're getting finer than that no matter what in your XY, and then you can pick how thin you want it in the vertical direction. So but these all have little text on them. I mean, this has text on it that you can see that comes out just fine. So we do a lot of embossed engraved text, super thin walls. You don't really have too much of an issue with it, yeah, so that might be a good litmus test if you wanted to send something over like that, just to see what it would look like. And we have standard samples too, obviously. If you just want something, I'd be happy to send it to you.
Sure.
Mm-hmm.
Okay, yeah, that's what I got.
Cool. Oh, yeah, Stuart. Oh, sorry. You responded. Thank you for that, Flake. Yeah, yes, okay, so you've been using Shapeways. We have some people that actually do both too. They had Shapeways and then they brought ours in-house. But you'll have better resolution probably than what you're getting on some of those, just based on what I've seen with some customers for architectural models. I would say if you have, same thing, if you have a particular part you exported from SketchUp, you just want to see apples to apples, you've had it printed on Shapeways and you want to see what it looks like on our technology. If you send it to me, I'll print it for you, and I'll send it back, and that way you aren't just taking my word for it. You can see what it looks like. But you should have pretty good surface finish based on some of that smoothing technique that we have built into our software in our printer, and you'll be able to see some high detail as well. So yeah, let me write that down too, so I make sure that I touch base with you guys. Okay, cool. What other questions do you have? Or are there things that you guys, based on your use of additive, you're like, man, is this ever going to come down the line? Or, here's a huge need I have. the common misnomer is folks think, oh, I can do, 50 parts on that. And then after that, it's not cost effective to do 3D printing. And I have people that are doing wholesale orders of about 3,000 parts at a time and just whipping them out in a couple days. So that speed can start to help too, as you're bridging the just one-off, I need a couple, all the way up to I have a large wholesale order that I want to fill additively on demand versus, cutting steel or aluminum or trying to tool up for that. So.
Danny, you talked a few times about changing materials over. What's that like? And you have a vat that you make. Does that already include the material, or?
Yeah, that's a great question. So it's not a cartridge where it's automatically refills. It's just it's a resin tray, and then the material comes in its own bottle, and you get 2 trays with the printer. So let's say I'm always printing in these 2 materials. You don't have to change them out. But if you do need to, you just drain the resin into the bottle. There's a filter and stuff, and you just clean it. Include, a little spatula and a microfiber cloth. And then you can reuse it. But you can leave material in the vat. It comes with a lid, so it's not exposed to UV light, and nothing will happen to it. You just need to stir it again so it's mixed properly when you go to print it. But it's pretty easy change out of material. And the other nice thing is, some systems you have to fill in because the resin tray, if you will, is included in the machine. You have to use a lot of material. This one you can use as little or as much as you want because they're individual popping out trays into the printer. So if you need just a short run of something, you don't have to waste a bunch of material or go through a real laborious process, just flopping them.
Very good.
What's the shelf life on the material? How long?
For resin? Yeah, so we recommend a year. We warranty it for a year. Obviously, if it's in a temperature neutral spot, like not, South Dakota outside in any season, it can last longer, not exposed to that UV light, but we recommend about a year.
And I've cheated that quite often.
Yeah, many people have, yeah. So if it's in a good spot, it'll last longer.
What happens? What is the key to knowing that your material is aged out?
Most of it, I actually don't ever see a problem. On some of the more viscous materials, if it like that nylon 6, if it's not being shaken super vigorously when you use it, what people can find is if their chemical composition, it's just like slowly changes over time, and then you get to the bottom of the bottle and it doesn't have the, you know what I mean? And so I find it more not with the time that it's left in there, but just the consistency and the process that they're following with some of the materials that need it. And it's not, anything crazy. I can shake it and it'll work. But if you have a bottle that lasts a lot over time, sometimes I can see that. Otherwise, it won't solidify or anything like that, as long as it's in that bottle in a temperature kind of neutral area.
I guess I wanted to clarify. So you said one part versus like an array of all the same parts would print at the exact same because it's a on-off type situation?
Yep, it's exactly that. So it's like if you think about slicing those layers, you're turning on an entire layer at a time. So that it doesn't care if it's one part here or 12, it sees it all as one layer because you slice a build table's worth of parts, not individual parts that it has to go trace, which is kind of how SLA works.
Right. Okay.
Yeah.
Thank you everyone for joining us today, and keep your eyes open. We will be having another session in a couple of weeks. Don't know what the topic is, but I take suggestions and I take volunteers if anybody wants to host up. Again, I want to thank everyone, and if you have any questions, reach out to Danny. If you have any comments, reach out to me. So.
Perfect. Yep, hit me up anytime.
All right. Thank you so much, everyone. Appreciate it. Take care.